Good afternoon to one and all present here. My name is Anandakumar. I am from Computer Science Department. So, I am from Ratnam College of Arts and Science. Today, I am going to take the topic of the logic circuits and circuits from the digital electronics. First of all, what is the logic gates, truth table, types of circuit, combinational circuit? So, these are the content today I am going to discuss about this class. The building first, what is gate? Gate is a building block used to create a digital circuit. So, any kind of digital circuit is built using a gates, or it is a combination of gates. So, there are various kind of gates exist in the digital circuit. Basically, so the basic block is the universal gate is the NOR and NAND gate is the universal gates. Okay. So, these gates are the build the overall digital circuit. Then, so these are the basic gates. So, the basic gates are first the NOT gate. NOT gate means it is a complement. So, if you give the input as a input, that will be complemented. If you give the true, it will give the false. Okay. AND gate means if the two input is true, then we get the final result as output as a true, otherwise we get the false. Then the OR gate, if any one input is true, we get the result as output as a true. The NAND gate is the NOT plus AND. So, the NOT plus AND means, so we get the result as a opposite of the AND gate. That means, if the two input is true, then we get the result as 0, otherwise we get the result as 1. Then NOR gate is the opposite, NOT plus OR gate. So, we get the result as a opposite of the OR gate. That means, if the two input is 0, we get the result as 1, otherwise we get the result as 0. XOR and XNOR is the combinational circuit. We make the different type of circuit to form a XOR circuit. If the two input is same, we get the result as 0. If the two input is different, then we get the result as 1. In a XOR, it is opposite of the XNOR. So, the buffer gate is it store a buffer information. That means, the temporary RAM informations are stored in the buffer gate. So, here, so these are the circuits. Here, this is the circuit. Here, A is the input, then we get the result as a output. That is the complement. Here, if the input is true, then we get the result as output as false. Okay. So, this is the truth table. 0 means false, we get the result as 1. 1 means true, we get the result as false. Okay. Then AND gate. Here the two input is 0, then we get the result as 0. Otherwise, we get the two input is 1, we get the result as 1, otherwise we get the result as 0. Then, so here OR gate. So, if the two input is 0, we get the result as 0. That means, if the two input is 0 or false, we get the final result as 0. Otherwise, we get the result as 1. Then, next NAND gate. NAND gate is so here the two input. Here the two input is the two input is 1, we get the result as, finally we get the result as 0. Otherwise, we get the result as 1. It is opposite of AND gate. Next, XOR gate. Here, so the input is, two input is different, then we get the result as 1. Otherwise, we get the result as 0. So, next XNOR gate is if the two input is different, then we get the result as 0. Otherwise, we get the result as 1. So, this is the basic gates. This is a buffer gate. Buffer gate means if you get the input, then we get the result as output. Here, if you give the 0, we get the result as 0, output as 0. Okay. So, these are the overall detail about the basic gates. Thank you very much for attending this class.